Question 9. We are given u equals 3 plus I over 2 minus I. Part 1. Express u in x plus iy form. Part 2. Modulus and argument. Part 3. Argand diagram and locus. Part 4. Least value of modulus z. Let's start with Part 1. Part 1. Express u in the form x plus iy, showing full working. Multiply top and bottom by the conjugate of 2 minus I, which is 2 plus I. This makes the denominator real. Start with u equals 3 plus I over 2 minus I. Multiply numerator and denominator by 2 plus I. Expand the numerator using FOIL. First 6, outer 3i, inner 2i, last I squared equals minus 1. Remember, I squared equals minus 1. Collect the numerator, 5 plus 5i. Now expand the denominator. Move earlier work up to make room. Use difference of 2 squares, 2 minus I times 2 plus I equals 5. The imaginary part disappears. Combine numerator and denominator. U equals 5 plus 5i, all over 5. Split into real and imaginary parts. U equals 1 plus I. Next, Part 2, Modulus and argument. Part 2. Find the modulus and argument of u equals 1 plus I. Modulus, root of 1 squared plus 1 squared equals root 2. Argument, both parts positive, so first quadrant. Arctan of 1 over 1 equals pi over 4. Summary, modulus root 2, argument pi over 4. Parts 3 and 4, Argand diagram. Parts 3 and 4. Plot u, draw the locus modulus z minus u equals 1, and find the least modulus z. Draw the Argand plane. Mark u at 1 plus I. Show modulus root 2 and argument pi over 4 from the origin. Draw the locus, a circle centered at u with radius 1. The least modulus z is the point on the circle closest to the origin, modulus u minus radius, root 2 minus 1. Working, modulus u is root 2, radius 1, so minimum modulus z is root 2 minus 1. Summary next. Summary. Part 1, u equals 1 plus I. Part 2, modulus root 2, argument pi over 4. Part 3, circle center u radius 1. Part 4, least modulus z equals root 2 minus 1. That completes question 9.